Hi guys, in this lesson we're going to talk about solving quadratics by completing the square and taking the square root. Let's look at these examples. We have x squared equals 16, and to have x by itself I need to get rid of the square by taking the square root of both sides. Square and square root cancel each other, which makes me end up with x. Square root of 16 is 4 because 4 times 4 is 16. And also, square root of 16 is negative 4 because negative 4 times negative 4 is 16. So we have two answers, x equals 4 and x equals negative 4. Now let's take a look at the second example where we have 5x squared equals 20. So in this example, before I get rid of the square, I need to get rid of 5 first. 5 is multiplied by x squared. That means I need to divide both sides of the equation by 5, which can make me end up with x squared equals 4. Now I can take the square root of both sides to get rid of the square. And I'm going to end up with x equals 2 because 2 times 2 is 4. And I'm going to end up also with x equals negative 2 because negative 2 times negative 2 is 4 as well. Third example, we have x squared minus 5 equals 44. Again, before I get rid of the square, I need to get rid of negative 5 by adding 5 to both sides. X squared equals 44 plus 5 is 49. I can get rid of the square right now by taking the square root away from both sides. X equals 7 because square root of 49 is 7, and it's also negative 7. So x equals 7 and x equals negative 7. Now, in the fourth problem, we have a different scenario. We have the square with numbers and dx in the parentheses. So the first thing I need to do to be able to get rid of these parentheses is to get rid of the square. That's why I'm going to take the square root first of both sides. Because now the square and the square root cancel each other, and I'm going to have whatever in the parentheses free. X plus 10 equals radical 6. And since I don't have a square root for 6, I'm going to keep the radical in the simplest form, which is radical 6. Now, to solve this problem, I need to also understand that the radical is not just the positive radical. We also have the negative radical. So I'm going to end up with two equations. X plus 10 equals radical 6, and x plus 10 equals negative radical 6. So the same way we had a positive and a negative answer when we square rooted the numbers in the previous examples. So now all I need to do is to take away 10 from both sides of the equation. I'm going to end up with x equals radical minus 10 plus radical 6. Same thing for the other equation. Take away 10 from both sides, and I'm going to end up with x equals negative 10 minus radical 6. Now let's take a look at this quadratic where we have it in the vertex form. So this is a vertex form of the quadratic. I have x plus 4 squared minus 5 equals 0. And to be able to solve this equation by for x, I need to get rid of negative 5 first by adding 5 to both sides of the equation. So I'm going to end up with x plus 4 squared equals 5. Now I have a similar question to the previous example, where I have to take the square root of both sides first because I have numbers and variables trapped in parentheses with the square at the top. So I'm going to have to square root first because the square and the square root cancel each other. And now x plus 4 is free from the parentheses, which is equal to radical 5. Radical 5 is in the simplest form. I cannot simplify it. And at the same time, we also now know that we're going to end up also with x plus 4 equals negative radical 5. So we have the positive root and the negative square root. So now all I need to do is to take away 4 from both sides of the equation to solve for x. And I'm going to end up with x equals negative 4 plus radical 5. And then same thing for the second equation where I have to take away 4. And then I'm going to end up with x equals negative 4 minus radical 5. Now, let's take a look at this quadratic where we have x squared plus 8x plus 6 equals 0. And to be able to solve by taking the square root, I need to complete the square and have a perfect square first. So the first thing I need to do is to have a perfect square by completing the square. So this is a trinomial with a leading coefficient of 1, which means it's easier to deal with. All I need to do to be able to complete the square is to divide the middle number of the trinomial, which is 8, by 2, to get a 4, and square that answer, which is 16. Now, to have a perfect square, I need to add 16 to the second term of the trinomial, x squared plus ax plus 16, and take it away again to keep the value of the equation the same, plus 6 equals 0. Now I end up with a trinomial that I can factor into x plus 4 times itself. And negative 16 and 6 are like terms that I can put together or combine together to get a negative 10. Now I can write this trinomial as, or this quadratic as x plus 4 squared minus 10 equals 0. Now this is the vertex form of the quadratic. Now to solve this quadratic, I can add 4 to both sides to have the perfect square by itself on one side of the equation. So I'm going to end up with x plus 4 squared equals 10. Now, x plus 4 is trapped inside the parentheses with the square. So the first thing I need to do is to take the square root of both sides of the equation. This will give me x plus 4 equals radical 10, which is the positive radical, and x plus 4 equals the negative radical 10. So I'm going to take away 4 from both sides to be able to solve this equation for x. And I'm going to end up with x equals negative 4 plus radical 10. Same way for the other equation where I have to take 4 away from both sides of the equation, and I'm going to end up with x equals negative 4 minus radical 10. And since radical 10 is in the simplest form, so these two answers are in the simplest form for x. First, I need to identify what the values of x are in decimal. So I have negative 4 plus radical 10, and the answer in decimal is negative 0.8377, which I'm gonna round into negative 0.838. Now the second value is negative 4 plus minus radical 10 minus negative 4 minus radical 10 which is equal to negative 7.1622, which I'm going to round into negative 7.162. So now I need to put the quadratic in the calculator. I'm going to put x squared plus 8x plus 6, and I'm going to graph my quadratic. I'm going to try to find the zeros, so I'm going to hit second trace, 2 to give the 0. The calculator is asking me for the left bound. I'm going to move my pointer to the left of the right 0, enter, and then I'm going to find the right side of the right 0, and then I'm going to hit enter. So the value is negative 0.87377, which is, we can round into negative 0.838, which is the first 0 that we got in the equation. Now let's find the second 0. So I'm going to hit second, trace, 2, and then I'm going to get closer to the second 0 on the left, or the x-intercepts on the left. So I'm going to need to be to the left of that value. So I'm going to hit enter now. I'm to the left. And then I'm going to move the pointer to the right of that value. And I'm going to hit enter. And then the value is negative 7.1622, which we rounded into x equals negative 7.162, which is exactly what I got when I solved the equation. So that verifies my answers algebraically.